Hello and good day, Algebra. We are starting Unit 7, which is a real short unit. It's kind of an intro unit to parabolas. It's a precursor to quadratic equations and parabolas. And we're starting with PO49, which is factoring a trinomial in x squared plus bx plus c form. So in Unit 6, we learned what a trinomial was, okay? We've dealt with equations in this form before in PO45, where PO45, I gave you a binomial times a binomial, and you used old man FOIL or crab claw or the box method to multiply them, right? And your answer was always a trinomial that looked kind of like this: x squared plus 7x plus 10. And so there was even an extra credit question for PO45 where I gave you the trinomial, and I said, what two binomials would multiply to get this answer? And a number of you got it correct. And what you were really doing was factoring it, right? We've heard that word factor before. What are the factors of 60? Someone give me a factor pair of 60, yeah. 6 and 10. Okay, or 2 and 30, or 3 and 20, or the word factor just means what multiplies together to get our original expression or our original term. So with greatest common factor, you've done that before. We're just kind of upping the game here to factoring a trinomial expression. And our answer is going to be what two binomials multiply to get us the original trinomial expression, okay? So let's look at this first one, x squared plus 7x plus 10. And I actually already gave you the answer. The answer here is x plus 2 times x plus 5. I want you to tell me how I got there. What connections do you see between the answer, x plus 2 times x plus 5, and the original trinomial? Anything stand out to you? Emily? What's that? Yes, you may. Gabby? Yeah. The hardest part about factoring a trinomial expression is what numbers do I use, right? Because this x squared, and notice how all of our examples here start with x squared. That's because we're factoring these in the form x squared plus bx plus c, okay? So all of your answers are going to start with an x. Because whether or not you use FOIL or crab claw or the box, you get that x squared by multiplying those first terms of each set of parentheses together, x and x. So the challenge then is because what numbers do I put in there to make this work? And Gabby said she's recognizing that 2 and 5 have a connection with both our constants and our middle term in the original trinomial. She said, well, hey, 2 times 5 equals 10, and 2 plus 5 equals 7. And that's how we get x plus 2 and x plus 5. And if we go to the box method to check this, if we multiply x plus 2 times x plus 5 together, I mean, think about this. This bottom right corner here, isn't that always just the product of our two constants, 2 times 5? And then this 7x, where does that 7x come from? Well, it comes from combining the like terms that we get in the top right and the lower left. 2x and 5x. So what we're looking for here is we're looking for two numbers that multiply to give us the constant and add or subtract to give us that middle term. Let's look at the second one, where I also gave you the answer here. X squared plus 12x. Does that connection hold with the positive 4 and the positive 8 here? Is positive 4 times positive 8 32, which is the constant that I have here? Yes. Is positive 4 plus 8 positive 12, which is the middle term that I have here, that b term in x squared plus bx plus c? Yes. Let's look at the third one. X minus 9 times x minus 5. Does negative 9 times negative 5, notice I'm including those signs, negative 9 times negative 5 equal a positive 45. Yeah. Does a negative 9 plus negative 5, or just negative 9 minus 5, equal our middle term of negative 14? Yeah. So that's the relationship that you're looking for here. Two numbers that are going to multiply to equal the constant in your trinomial, but then also add or subtract to equal that middle x term. Okay? These next three examples here illustrate the importance of making sure that your equation is good to go here. Notice how in the top row, all of our equations equal 0. In order to factor a trinomial expression, it needs to equal 0. So these examples here are just showing that before we can factor, I have to move this over proper place between the x squared and the constant, and because I moved it over from one side of the equation to the other, it's now a positive x. So the same rules of opposite operations. Okay. In the next one, x squared equals x plus 30. Personal preference here, I always like to keep my x squared positive, because then I don't have to worry about signs with my x values, which one's positive x, which one's negative x, to get a negative x squared. I like to keep it positive. So I moved my x term over and my constant of 30 over to get negative x and minus 30 to make my equation equal 0. Then I can go ahead and I can factor. The third one, x squared minus 22x equals negative 120. I just moved my negative 120 over, made it a positive 120, put it in the C place, that constant place, so the equation equals 0. So if go to the second page, some of them don't equal 0. All you're doing is using opposite operations to move the terms over so that it does equal 0. Okay? But let's look at some on our own here. X squared plus 11x plus 28. What I'm looking for are two numbers that multiply to make 28, and those same two numbers add or subtract to make 11. Which one do I want to start with? Do I want to start thinking about numbers that add or subtract to equal 11, or do I want to start with numbers that multiply to make 28? Brady? Why?
Because if you find the ones that add up to be 11, it
could not be factors of 28, and I want to be doing that for a while, right? Is there an end to the numbers that add or subtract to make 11? No. 8 plus 3, 10 plus 1, 15 minus 4, 100 minus 89, right? There's an infinite number of combinations of numbers that add or subtract to make 11, but not so much that multiply to make 28. Really, I'm looking at 1 and 28, 2 and 14, or 4 and 7. One of those three combinations has to be my answer. So then, which one of those factor pairs can I use to add or subtract to make positive 11? Noah? 4 and 7. So, the two binomials that are going to multiply to equal x squared plus 11 plus 28, they're both going to start with an x, because that's how I get that x squared term. But then one of them gets a positive 4, and the other one gets a positive 7. And whether you do or the see how this matches up here, right? Just using old man FOIL here. X times x gives me that x squared term. 4 times 7 gives me my constant term 28. And then that 11x comes from combining my inside and outside. 4x plus 7x gives me 11x. That's a good old man FOIL right there. Howdy. Okay. Lucas. Good question. Does it matter which set of parentheses gets the 4 and which one gets the 7? Why not? Because it's multiplication, and what do we know about multiplying stuff? Order doesn't make a difference. So if you put x plus 7 times x plus 4, it'd be the same thing. Okay? Let's look at the next one. X squared minus 9x plus 18. Again, we're looking for two numbers that multiply to make 18, and those same two numbers add or subtract to give us negative 9. So starting with the 18, what are our only options? What are the factor pairs of 18? Brent? 3 and 6. Sorry, I have a habit of always putting the smaller number first. I can't control it. It's just OCD. I don't know. But 3 and 6 is an option. Yes. 2 and 9, maybe? Yep. And what's the other option? Don't forget about this one, because it will come up from time to time. Yeah? 1 and 18. Okay? So, those are our three factor pairs that multiply to make 18, which means that the numbers in our parentheses have to be one of those pairs. We know that each set of parentheses has an x, because that's how we get that x squared term. And so now we're looking at what combination, 3 and 6, 2 and 9, 1 or 18, can we use to get a negative 9? And here's the best part. You can give it whatever signs you need to make it work, right? I used plus 4 and a plus 7 here because positive 4 plus 7 is positive 11, and positive 4 times positive 7 is a positive 28. Don't let negative 9 throw you off too much here. What can we use? Negative 3 and negative 6. Okay? In order to get negative 9, they both have to be negative. Does that work with our positive 18, though? Yes, because a negative 3 times a negative 6 is a positive 18. Isn't this great? Yeah? Next one. X squared plus 12x minus 45. Starting with that constant, what factor pairs do we have to pick from here? Brent? 5 and 9? What else? Lucas? 3 and 15? Noah? 1 and 45. Which combination is going to add or subtract, giving it whatever signs you need to get us a positive 12? Can you make a positive 12 from 5 and 9? How about 3 and 15? How about 1 and 45? Soybe? How? 15 minus 3. Good. A positive 15 and a negative 3 combine to give us a positive 12. Do positive 15 and negative 3 multiply to give us negative 45? Then we're good to go. Okay? Questions so far? Because this last one throws a little bit of a curveball. You've got to be a little bit careful here. Okay? X squared plus 5x minus 6. We're going to start the same way as we did with the other ones. We're going to list the factors of 6, which are 1 and 6 and 2 and 3. Yeah, so the problem you might see here is that, wait a minute, I can make a 5 with both 1 and 6 and 2 and 3, right? 6 minus 1. Right, we have to look at what they have to multiply to be also, okay? If we use x plus 2 times x plus 3, which we would need to because that's how you get a positive 5, notice that positive 2 times positive 3 is a positive 6. That doesn't match what we have in the equation. So this is out, okay? Elise says, let's use x plus 6 and x minus 1. Well, positive 6 minus 1 gives us positive 5, and positive 6 times negative 1 gives us negative 6. Okay? So you really need to make sure that the factors that you choose work through the whole thing. Usually, it's just going to be one of them, 3 and 6, 3 and 15 here, but if they both work, then you kind of got to go that extra step and just check and make sure. How are we feeling? All good? Okay. I want you to try the next 3 on your own if you haven't already. I'll pause the video, take any questions you have. We'll come back and some answers here. But go ahead and do these next 3. Notice how it says factor each trinomial if possible, which does tend to insinuate that there might be a situation where it's not factorable. We'll see if we come across that in the 3 here. So go ahead and work, and we'll come back to it shortly. Answers to the 3 on the first page here. Picking up where we left off here, we've got that constant of 3. So 1 times 3 is 3. He gives us that middle term of 4. So x plus 1 times x plus 3. Second one, factors of 100. We could go with 1 and 100, or 2 and 50, or 4 and 25, or 5 and 20, or 10 and 10. Okay? You will find here that how well you know your factors is going to play a major role in how successful you are with this. Okay? Because if you're, spending lots of time finding all the factor pairs, or you miss a factor pair and it ends up being need, right? Then you can run into some issues here. But given what we have here, how can we make a 20 from one of those pairs here? So maybe 10 and 10. How do we use 10 and 10 to make a 20? 10 plus 10. So x plus 10 times x plus 10. Okay? Times 10 is 100. 10 plus 10 is 20. The last one here, x squared plus 10x plus 16. We've got 1 and 16, 2 and 8, 4 and 4. We want to make that middle term of positive 10. 2 and 8 gets us there. So x plus 2 times x plus 8. Right? Those that have jumped to the second page, have you found one that's not possible yet? Yeah. Which one is not possible? Let's take a look at an example of one that's not possible. What'd you find? Fourth row, first one. X squared plus 6x plus 10. Okay? And what makes this one not factorable? What makes it not factorable? Gabby? Right. No factor pair of 10, add or subtract to make 6. Okay? The third one in this row also? Yeah. Ooh, I was getting salty by the fourth row here. I was 1 and 50, 2 and 25. I always think 50 should have more factor pairs than just 3 of them for how round of a number it is, but only just have the 3. What is wrong with this? I can see we can make a 15 from 5 and 10. Why not? Oh, drat, right? How we get a negative 15 here is from x minus 5 and x minus 10. So it works for the middle term, but then we look at multiplying our constants, and negative 5 times negative 10 is a positive 50, not negative 50. So it's not factorable. Does this mean that this is an invalid equation, or that there's no value for x that makes it true? No. It just means it's not factorable. It's as if I asked you to factor 7, and you said, well, the only way to factor it is 1 and 7. What does that tell you about 7? What do we call a number that only has factors of itself in 1? Prime. So this trinomial is considered prime. Okay? Prime just means that it doesn't have any factors other than itself and 1. We run into this situation here. Okay? So calling that one prime, calling this one prime, it just means that it can't be factored. Brent? How do you do the third row? The whole row? It's a lot to ask. Like one of them. Oh, okay. Going up to the third row. Ooh. Pick one that you want to Okay, so this was like what we talked about on the front page here, where in order to factor this, we want it to equal 0. Okay, notice that most of these on the second page, they all equal 0. I put that in there just to show you that everything is on the same side. Our x squared term, our x term, our constant is all on the same side, which is not the case for the third row here. So which one would you like to do, Brent? Second one. X squared minus 12x equals negative 35. We want to rewrite this so that it equals 0. Okay? Which means that we want to take that negative 35 and move it to the other side. And whenever we move something from one side of the equation to the other, what do we need to use? Opposite operations, right? We're going to add 35 to both sides, which when we add it to that left side, we can't combine it with the x squared. We can't combine it with our x term. It's our constant. It's going to be x squared minus 12x plus 35 equals 0. And now we can go ahead and we can factor it. Okay? So for the first one, you want to move that negative 17x over. Make sure you put it in the right spot, right? This is going to go in between your x squared and your constant term. And then the third one there is that x squared term. You want to move over to the other side. Make sure you put it in the right spot. It's going to go out in front of your other terms. Okay? Anyone run into any other issues? Noah? Last row, first one. Let's see what it is. Oh, it's right there. Okay. So this one is kind of the same thing as that third row there, where it doesn't equal 0. So our first step is we're going to take that negative 3x and move it to the other side and put it in its proper place, which is between the x squared and the constant term. Remember our talk about standard form last unit? This is why. We want this to be in standard form. So x squared, when we move that negative 3x over, it becomes a positive 3x on the left side, and then plus 18 equals 0. Okay. So now we go to our factors of 18, which are 1 and 18, 2 and 9, 3 and 6. How do I make a positive 3 from one of those factor pairs with addition or subtraction? Josh? Oh. Don't be such a negative Nelly, Josh. Don't tell me what you can and can't do. Right. So we can make the positive 3, right? If we do x plus 6 and x minus 3. But the problem is, what Josh was saying, is that you can't completely factor it because x plus 6 and x minus 3, those two constants give us a negative 18 instead of positive. Therefore, this is prime. Okay? This is prime. Any others? I saw a hand up over there. Also, when I asked for questions earlier. Any others? We're all good. Soybe? Yeah. So back to that third row there. When you've got that 25x plus 100 equals negative x squared. In order to make this equal 0, we're going to add x squared to both sides, and we just have to make sure that we put the x squared in the right spot. Okay, it's going to go in front of our x term and our constant. So what we're factoring is x squared plus 25x plus 100. And then x squared is now positive because we moved it to the other side. Okay. One final thing that came up in the last class was just more of a reminder than anything else. This one here, x squared plus x minus 42. What's your coefficient to that x term there? 1. Okay, so you're looking for factors of 42 that add or subtract to make a positive 1. Right? It's not written, but it's a coefficient of 1. Okay. Anything else? This is homework for tomorrow. We'll go over answers then, and then we will move on to PO50. So that's exciting for all. That's how you math.